right, here we go. Hello, everyone. My name is Cy Venom, your host for today. We've got an exciting episode for you today. Hopefully, wherever you're tuning in, you're ready for our episode. Drop a line in the comment. Let us know where you're tuning in from. The reason I'm so excited for our episode today is because we're bringing back Lucas Duarte, who is one of my favorite AI/ML demo gurus here at AWS, and he's got an awesome demo lined up for us. But also, we've got Anton here, Principal Solutions Architect at AWS, and overall expert in so many different things. You kind of have to be as an SA Solutions Architect at AWS. Our topic today, we're going to be focusing on a very specific generative AI use case. It ties in nicely to CI/CD pipelines, automating workflows, and we're going to be tackling security, which is, as most of you probably know, priority number one at AWS. But before we jump into the demo, I want to very quickly introduce my guests, give them a chance to introduce themselves. So Anton, tell us a little bit about yourself and what we're going to be talking about today.
Yeah, absolutely. So one thing I probably forgot to mention is that we go way long back, right? We know each other, I don't know, probably close to 10 years. I don't know, right? So I'm a principal solutions architect at AWS. I primarily cover serverless technologies. Okay, I work with ISV customers, helping them to make the best use of AWS, make sure their workloads are mostly optimized and bring the most value. I'm based in Austin, Texas, sunny Austin, Texas. I think most of us, if not all of us, are right. And I've been doing this cloud stuff for, I don't know, as long as I can remember, easily getting close to 2 decades, right? And the fun thing, before getting into the serverless world, I have quite a few years in cloud security space. So this topic, which we'll be discussing today, is very near and dear to my heart.
Awesome. Anton, at the end of the episode, I want to ask you a question. What is the secret sauce for success in a solutions architecture role at AWS? We want to hear from you. I know our folks in the audience want to hear from you as well. And if you want to hear this, be sure to stick till the end, and I'll have Anton share some of his insights. Next, we've got Lucas. By the way, Anton, you're right. We're all here in Austin, Texas. It's a beautiful day outside. Lucas, how are you doing today, man? Tell us a little bit about yourself, what you'll show today.
I'm doing great. First of all, thanks for inviting me, Simon and Anton. We are pleased to be here. I think this one of the topics that I like the most to talk is how to build simple solutions that can be pretty effective. And some people think that it's super complex to use Gen AI. They think that it's impossible to build something like that. So I think the idea of today's presentation discussion that we're going to have is show people that you can actually do a lot of things if you know at least where to start, information that you get, the data that you're talking about. But to introduce myself, for those who don't know me, I'm Lucas Duarte. I'm a container specialist at AWS. I support the same customers as Anton. We are basically in the same team, partnered together a lot. I've been in AWS for about almost 5 years now, most of that time in Brazil, but now I have moved to the US for about 2 years ago, and since then I'm living here in Austin, Texas, the same as you guys. So I'm excited to dive into the content today, Sai. That's it.
All right, let's do it. Lucas, I know we had talked about you showing us a little sneak peek of your demo, basically the final state of what we'll accomplish, and then we kind of work backwards and we show the steps to get there. Let's take a look.
Let's take a look at that. So the idea of what we have, folks, is we have ECR repositories, and usually those repositories, they have images, of course. When we create a repository, we use that repository is mapped to, usually that image repository is mapped to a code repository. So in this case, for example, I have my awesome application here. And my awesome application is an image. We have enable inspector for that. And what inspector gives us, it's basically the vulnerabilities that are there present in that image by level of them. So we got some critical, some high, some medium. Of course, we did all that in purpose for you, so we could demo that for you today. So that's the idea. And at the end, what we're trying to get is a security validation of those CVEs. The scope of that demonstration will be around updating the requirements.txt file. In this case, is a Python application. But the idea is with the information, with the data that we're going to collect from inspector, We are going to interpret that data and basically generate a model completion with some prompt engineering here and there to have something like that. So a PR open to the application repository with the requirements of the libraries that you should update, along with the updated requirements, but not only that, with the changes in the requirements.txt file as well, updating the libraries from one version to another. So this is the outcome. And if you want to know how we are achieving that with GenAI, stick to the end because we're going to do that at the end of the presentation so we can get you folks for longer here with us.
Awesome. Thank you, Lucas. All right. Now, I think the coolest part about that is that PR that you saw was generated by a robot, basically. It was all automated. And maybe a human comes in to hit that merge button, but all of that you saw was automated. So I think that's what we want to understand here today. How can we automate some of these tedious tasks with containers? Specifically, we're going to dive into security. Now, Anton, first question today here for you. I know that a lot of this stuff has been figured out in the past. There's security solutions out there, open source things, third-party solutions, there's Inspector, there's Guard Duty. There's ways to do this today. Mm-hmm. So what makes this unique? Why are we reinventing the wheel here, or are we tackling a real problem that exists with solutions that are already out there today?
Now, we're tackling a very real problem that exists, right? And, security is one of those things, one of those areas where you never stop, right? You're never done with your security stuff, right? So today specifically, we're talking about CVEs, right? Which stands for Common Vulnerabilities and Exposure. Now, if you look at cyber threat index reports, right, there are roughly 3,000 new CVEs discovered per month, right? So roughly 2,900, getting close to 3,000, and the number will grow, okay? This is a huge number. And realistically, right, if you look at how those CVEs are patched across customers that we work with, different organizations, Lucas, if you can switch to the next slide, right? You see that the process is still not as efficient as we would like it to be, okay? Yes, there are a lot of tools there, and it's not just dependency patching, right? You have tools, for example, like SonarQube that will do static code analysis. There are a lot of security tools, but in many cases, those tools will give you guidance, right? They will provide you with report. They will get your recommendations, but it's still up to you to implement that. So if you look, at a few data points we have on this slide, right, you can see that the mean time of remediating a CVE is still around almost 2 months, right? So from the day that CVE is discovered, it takes 2 months. In security world, that's in eternity, right? And you can see the bottom left, this is one of my favorites, is 75% of attacks in 2020 used vulnerabilities that were at least 2 years old, right? So this is crazy. Those vulnerabilities are out there for years, and a lot of microservices, a lot of containers, a lot of software that we see being built is still not patched. So today, what we want to talk about today is how we can actually address that, right? Now, the problem with this, Lucas, if you want to click to the next slide, is we kind of already touched on that briefly. The process is quite manual today, okay? Now, there are tools for identifying vulnerabilities. There are tools for analyzing vulnerabilities. There are tools for risk assessment. But in order to actually complete the cycle, the remediation part, right, you need to understand who's responsible for each one of these, right? And you can see still that at each one of these phases today, there's still human intervention required, right? So if you look at tools like Inspector, for example, that we'll be using today, Amazon Inspector, it is awesome at scanning images that you put to ECR and providing you the report of what needs to be fixed. But it's still up to you, a human, right, to fix that. And this is a very mundane task, right? Because these things, they never end. New CVEs are discovered all the time. So what we want to talk about today is how we can actually automate some of that using GenAI capabilities.
Makes sense. Now, Anton, I've got to ask, this almost is, it's like a flywheel to me. This flow is something that I'm very familiar with because there's a lot of all-in-one security solutions out there that claim to do this that work with source code, that kind of thing. And I also think about things like Dependabot, or it's like a GitHub Actions workflow that automatically opens PRs for dependencies that need to be updated. What's different between those solutions and what we're going to be showing today?
So there's some overlap, right? Obviously, there are different solutions in the space, but there's always an overlap, right? The solution that we've built, right, we started with a very specific use case. We want to scan container images, right? And we want to discover CVEs that are applicable to those images. And we want to simplify the patching of those CVEs literally to one click where applicable, okay? But one of the goals that we had is this is not the end of it. This is just the beginning. We want to understand what the workflow looks like, and then let's expand that, right? So in our solution, like I mentioned, we'll be using Amazon Inspector, right? But how you can actually apply any other tool and have the same workflow, right? We'll be using Bedrock, right? How can you apply any other tool and use the same workflow? So the idea that we have here is we're giving a framework, right, of the solution with some specifics implemented. It's already available on GitHub, but we encourage you, as solution as architects in general, to actually see how you can take this baseline and apply it to your environment, because maybe there are tools that you're using and we're not aware of. How can you easily integrate those tools and do what you do today, but in a much more automated way?
Makes sense. And now you mentioned Bedrock. And by the way, I've been using Bedrock quite a bit myself, actually, from little helper tools locally to, automating PR reviews. I just find it so convenient to just have an API that I can hit and easily modify to hit like 10 or 20 different models that exist within Bedrock. So I like the service. And I can see that there's a lot of potential for different use cases with it. Where does that fit in today for what we're going to be showing?
So, Lucas, you want to do that slide where we have like Bedrock and Inspector?
Sure.
Right. Yeah. Let's keep a few of those. Right. So, like you said, right, Bedrock is used to, it's a service with LLMs, right? And you use it to generate content based on what you ask it to generate, right? And that's essentially exactly what we wanted, right? So one of the keywords that I've mentioned, a few minutes ago is mundane, okay? Now, this task of patching CVEs, which is most commonly updating your requirements, .text or package, basically updating your dependencies. This is a pretty, mundane task, which doesn't really change a lot, right? You need to make updates, you need to validate that it works, you're done. But the problem with it is it never ends. You need to do it all the time. So this is where we wanted to use the power of Gen AI. Right.
Can I also go back to one thing that Sai said? I think like the idea of the solution, if you get what we are basically doing and compare that to Dependabot, it's basically the same thing, but we needed to start somewhere. So in order to see if the model would perform in the way that we are expecting, we would need to start with a use case that we already know that would work like with different softwares. So the idea here, as Anton said, is build a framework that we can work with some prompt engineering, even RAG in the future, to expand that capability more than only patching requirements.txt files. So for instance, we could easily implement something with prompt engineering to, validate a Docker file and update something in place in the Docker file. Or even, Sai, me and you, we have a custom kind of validation that we want to apply to all the repositories. Softwares like those that you said, like Dependabot and that stuff, they have a pretty specific feature use case that they apply to. Maybe the type of validation that I want to do is some kind of different within my company. So this is where like the power of Gen AI and work with prompt engineering and RAG can actually help. And of course, to act on top of the model completion, it will need like a little bit of code involved, tools, Bedrock agents, and all that type of stuff. So I think the idea here is to show that if you get what we did and you do it manually, it's basically someone talking to a model and building prompts. So the idea is show to people that what we do with LLMs as of now, with Bedrock, with like all the LLMs that we have available in the market. We're getting that idea and automating that somehow in this case for this particular use case. But the automation here is important, understanding how we are building the prompt, up to how many is what we call inference shots, up to how many examples we can have in a prompt and have a good outcome completion of my model. Should we increase the amount of parameters that the model support, or should we like add more examples? So I think like the idea, the use case is simple, but what we are doing with Gen AI could be expanded in many different ways. And this is actually what we are doing with some partners here in the team.
And we'll see a couple of examples of what we're talking about.
Awesome. Makes sense. So if I had to say one takeaway that you shouldn't take away after this episode is, if I implement the things that Anton and Lucas showed me, I'm going to be more secure with my containers. That shouldn't be your takeaway. The takeaway here is we're building a framework to allow you to automate using Gen AI, APIs, Bedrock APIs that allow you to implement security best practices, or honestly any best practices,
anything,
in a customizable way for your repositories. And I think that's the power here. It's not essentially a unique snowflake solution. It's a solution that can essentially fit everyone and can be customized to fit almost every use case. You mentioned a little bit about prompt engineering and RAG. Folks, we're going to get into these Gen AI terms in a bit more detail, I think, in a bit here. But Lucas, where do we want to go next? You want to show us an architecture diagram, or do we want to jump maybe straight into the demo?
No, I think this portion here is pretty important because that will connect exactly what the prompt engineering stuff that we're going to talk about. So Anton, if you can take this away, and then we move to the prompt engineering and start from there.
So, this is a high level, let's call it a workflow, right? We're going to get into architecture as well, right? But this is a high level workflow, what we're doing in our solution. So you always start with some sort of application, right? It can be, different languages, right? You package that as a container image, you push it to ECR, you'll see it in the following slides. Inspector will start the scanning process, right? And it will detect vulnerabilities. Everything, business as usual so far, right? You're going to get that report. So what's going to happen next is we're going to take that report, a list of vulnerabilities that were detected by an inspector, and we're going to create a prompt to Bedrock, basically telling us, hey, those are the vulnerabilities that we've detected. Can you please generate the content of pull request description and the content of code file updates, dependencies updates that we need in order to remediate those vulnerabilities? The Bedrock will generate that, and based on that information, we will actually automatically create a pull request for the repo. So you will see that is in the demo, right? As an engineer, your experience is you push your code to the repo. A couple of minutes later, you have a PR saying, hey, we've detected these vulnerabilities during the CI/CD process, and we've opened a PR for you to actually address those vulnerabilities, those CVEs. So as a developer, instead of getting a report and having to fix those on your own, you're getting a PR with suggested fix, right? And let's be frank, it's not always 100% bulletproof, but it's still significantly better than fully manual process. So you can either click merge, you can test it, right? Depends on your level of confidence, right? So as a developer, your job is significantly simpler, right? Because now you're, getting a lot of that mundane tasks automated. Now, when it comes to Lucas, if you want to switch to the next one, right? When it comes to in context learning, this is probably one of the coolest part of the solution, right? Now, there are different LLMs. Some of them are bigger, like you have larger LLM models, smaller LLM models, more generic LLM models, right? More specialized LLM models. Some of them are purely used for generating images, right? Some of the models are generic and can do anything. And there is a cost to running those LLMs, right? The smarter, the more generic, the more powerful that LLM is, usually it's going to be more expensive, okay? Now, the task that we're asking LLM to perform here is very, very specific. We don't need an LLM that can generate images or tell bedtime stories to my 4-year-old kid, right? We need an LLM that can do a very specific thing, okay? More than that, right? Moreover, we will actually provide an example of what the desired result looks like. We will tell the LLM, hey, this is kind of what we're expecting from you. That's the format, right? And that's the detected vulnerabilities. Can you please, based on these two pieces of information, generate the pull request content for us? This is very similar if you've ever at any job wrote a document or creating a PowerPoint slide, right? When you're tasked to do that, what would be your first question? Has anyone did something similar before? Are there any examples? Do you have any references that I can look at? This is literally very similar, right? We're telling that LLM, hey, take this as a reference and this as the input and generate us the result, okay? This helps to actually use not the most expensive LLM out there, right? This helps you to actually balance, right, between cost and what you're getting as a result. And honestly, yep.
Yeah, I just wanted to say, I think that makes a lot of sense. And I think one of the concerns that people watching might be having is that, generative AI, isn't it not deterministic? As in, you don't exactly know what the output is going to be. You could feed in the same input 3 times and get 3 different results. How am I ever going to trust this for my security posture? Well, Anton, I think what you're explaining here is that there are ways to make LLM behavior more deterministic. And one of those is by passing in context learning. But I think also the other is that the actual vulnerabilities are being found by inspector, which maybe they will use Gen AI features in the future. Maybe they already are. I'm actually not sure. But they have solid findings for which they're finding these vulnerabilities from. We're just using Gen AI to translate those findings into the PR.
Exactly. Right.
Without good data, we are not able to do anything. So here we have like Python, Java, JavaScript, and we're using Spectre to scan. But that same concept would apply to anything. Imagine if I have a Packer YAML file that I create EC2 instances, AMI, I have some validation that I want to do there, and I have a specific prompt engineering example to deal with that type of configuration. So this is like the possibilities that we can have here with like giving examples. And if you really think about in context learning, it's basically RAG. So when people talk about RAG, I don't think not so many people realize that basically we are retrieving an information, we are putting that information into a prompt and sending that to a model. That's it. And then that raises up the max tokens kind of questions and everything. But I'll stop here. Sorry to interrupt you, Sai. I think like I want to be part of the discussion with you guys.
No, you're good, and I love that. We're getting into like real Gen AI concepts here, like RAG versus in context. While we're on that topic, I got to ask you, Lucas. So when you can, in Bedrock, you can set up knowledge bases. Right. How does that fit in?
A knowledge base could really fit in with the stuff that we are doing. Basically, we could build a knowledge base with some of the examples, some of the validations that we want to do. An example of a security validation that an engineer did. So that knowledge base could be part of Bedrock, and we could basically plug that in Bedrock. And what would happen is once we send a request to Bedrock, the query that we send to Bedrock would be embedded. And basically that embedding, we would search for those keywords in the knowledge base that we have everything. So we could have like the security analysis, we could have documentation talking about how we validate security postmortems and all that stuff. So basically Bedrock would do the RAG for us, and for us we would be pretty transparent. So I think this is where a knowledge base would fit in, and this is essentially RAG.
Got it. So the secret,
I would add to that, right? So any solution is about scaling, right? You do not want to create the interstellar rocket right away, right? You want to start small and evolve over time. Being very, very transparent at this point in time, I think knowledge bases would be an overkill for us, okay? But as we evolve, yes, absolutely, right? Because at this point in time, you will see that in context learning example. Can it be done using knowledge base? Yes, right? Does it make sense? Not yet, okay? We're getting there.
I think the line where you have to decide to use those things is when you're hitting, maybe input token limits, which I think we're going to see we're nowhere close to that. I love this tangent we're going on, but Anton, I want to pass it back to you so we can finish going through this workflow and then jump into the demo, maybe see the architecture diagram as well.
Yeah. Well, let's actually do that. Let's go to the architecture.
Let's do that right now. Yeah, let's do that right now. So even before going to the architecture diagram, I want to go back to what I showed to you folks at the beginning of the presentation. Remember that we said that we are using context learning examples here. So basically, I had to build that in context learning example for the model to understand the task that it needs to perform. So let's take a look at that in context learning example that we have built here. Basically, I have two applications. And those two applications, they are pretty complex applications. The my awesome application. Let me open that for you. I hope you don't. Okay, so this is a pretty complex application, as you can see here. There's a health check that returns a status like 200. But the idea of that is that I have created that application with vulnerabilities in purpose. So if you look at the requirement side, sorry, this is in Portuguese, folks. That's the trade-off of like speaking many languages. You sometimes write in different languages. But the idea here is the libraries are all deprecated, so they all have CVEs, and I was expecting that. So what we did is we built that image, and we knew that image would have a CVE, and we pushed that image to ECR. Once the image is in ECR, we have inspector that we already showed that we have all the CVEs that it found, critical, high, everything that I was expecting. So with that in mind, what I did is I built the in-context learning prompt that the application will be opening the PR, it's going to use to open essentially the PR. It's using a random name here, but if you look at the vulnerabilities here, you're going to see that those vulnerabilities are basically the ones that are being showed here. And one thing that is cool about Inspector, though, as you said, Sai, we don't need to rely on the model to know about the CVEs. Inspector itself will show you the fixed version of the library. So you can actually use that and much more information that we could use for that type of validation. But this is just one example. So once we have it, I'm going to build a prompt. So for this application, those are the vulnerabilities that Inspector defined. This is your current requirements from the repository. So if we look into the requirements for my awesome application here, it's basically those requirements, right? So this is the current requirements. And then the suggestions for improvement is what I'm expecting the model to generate for me once I append to that prompt the next application. So this suggestions for improvement were created by me, but this is what I'm expecting the model to create once it opens the PR. So the next prompt would be this in context learning example plus this, and the rest would be up to the model to define. So in this way, we are influencing what the model can reply. So we are giving an example. You have the next example here. So the model knows, okay, I have one example of what I did before, and I need to do exactly the same thing for this new prompt that's coming. So that's basically it. I'm going to dive deeper more once we get to the architecture, but just to explain the in-context learning piece here that I think it's pretty important.
It makes sense. And you know, my favorite LLM that I use most commonly is Anthropic's Cloud 3.5 Sonnet. I believe that's their latest cloud LLM right now. And lately, you know, one of my more recent use cases, I've wanted it to review some Markdown in a project that I manage. And the first time I asked it to review, it just gave me a list of revisions. And I said, you know, I think it can be smarter. I want you to give me the entire Markdown file with the changes already in there, and then I can just copy paste that file in. I think that example is really similar because I'm telling it the exact format that I wanted to give it to me. I give it an example, and now every time I ask it to review a PR or a Markdown file, it gives it to me in a format that I can just copy in directly. So I think that's kind of the secret sauce here. You can do a lot with in-context learning. You can tell the LLM how to respond to you.
Even before thinking about fine-tuning, is what we said, like test with some prompt inferences, try one-shot, few-shot inference. Usually in the documentation, they say that up to 6 examples is good. If you have more than 6, probably you would like to change the model or even fine-tuning that model or have a knowledge base, something like that. But yeah, that's the idea. And you just explained it for Markdown, and that could be applied to actually any use case if you want to influence the model response.
Cool. And so with that example you passed in, it's a human readable example, right? You're giving action items. And I think that's because you don't want the LLM to automatically merge code changing PRs. You still want a human element here, someone that can go in there, see the actions, and then hit that merge button.
So that's an excellent question, right? Because at this point in time, me and Lucas, we met in the office, and we had an interesting discussion regarding, okay, how far we take this automation, right? And we made a very intentional decision. We will open a PR, but we will still leave the merging decision to an engineer, okay? Depending in the future how much that engineer will trust the system, how confident they are in the system, maybe at some point in time they will want to automate the merge as well, right? Because you can imagine this is continuous integration. The moment you merge, the same process will repeat again, right? So the fixed image will be once again scanned by the inspector, right? But at this point in time, when we were building the system, we said, you know what, that last step, we still want human to be involved there. Why? Well, I've been doing development for many years. Developers hate when someone changes their code without them knowing about that, right? So no one likes that. So we wanted to say, yeah, that last part, we want developer to be 100% aware of what's going on, and we want them to be responsible for clicking the merge button.
Makes sense. I can already see it in the future. Oh, you LLMs, get off my lawn.
Yeah,
I love it.
You run
All right.
team, and the one to blame is LLM.
I'm already seeing it. I look in GitHub. There's already these automated AI PR review agents going in, making changes, opening PRs. It's only a matter of time until they take over, right? Well, hopefully not. But Lucas, now we've seen the in context learning example. We see that inspector is giving you vulnerabilities. What's next?
What's next is the architecture diagram. So let's start with that. But before I start with the architecture diagram, in order for the demonstration to work, I'm going to push the image already to the ECR repository. So I'm actually doing that right now. And then I'm going to talk over the architecture diagram just to show you guys that I don't have any image in my amazing application repository. So you know that it's all live. So if it doesn't work, it's Sai's fault. Just kidding. No, but it's going to work. It's going to work. I hope that it works. So what I'm going to do now is basically push an image to my amazing application. And here I'm simulating a CI pipeline, right? So the outcome of every CI pipeline is to have an artifact somewhere. In case of containers, the artifact will be an image in the ECR repository or any other repository that you are using. So let me actually log into ECR. This is the folder with the Docker file and everything. Please ignore the super big path of my terminal. You don't want to pay attention on that. You don't need to pay attention on that. Let me build the application. I think we have some cache here, so it's going to be pretty fast. Then I'm going to tag, and then I'm going to push the image to ECR, and should be there pretty fast. So we're pushing the image to ECR. All the layers exists. Perfect. So the image is here. Now let's go to the architecture. So everything starts with the source code, as I just said. And then we have the continuous integration pipeline, basically what I just simulated. And just to recap on that, every CI pipeline, the outcome of it would be an artifact placed somewhere. If you're talking about front end, could be a zip that you deploy on S3. So that's the idea. So what we have in case of containers is the image on the ECR repository. And this is pretty important. With images, we are aiming to build just once, right? And then from each environment that we are moving forward, we are retagging that image and promoting that image and using basically the same image. So we push the image, we have that image in ECR. And as you can see here, the container is red. Because basically I have created a rule for inspector that if there's any critical or high CVEs, I would get the inspector sent to event bridge. So as soon as we have identified that there is a CV high or critical, we could change the inspector rules. Inspector is going to send that event to event bridge. Once the event's in event bridge, we have the finding event, which basically for every finding, for every CVE that inspector found in your image, it's going to emit a finding event to your event bridge. We are capturing that finding event with a Lambda function and saving that in a DynamoDB table. Now, the DynamoDB table is pretty important because the partition key that we are using is the same name of the ECR repository. So this is the way that we know which finding belongs to which application comparing the ECR. In order to scale that even further, we are planning to add some metadata here. at the ECR repository, but this is next in the demo. This is the next step, so I'm too excited. So after the scan has completed, we have an event called scan complete event. That event is it's pushed by inspector as well. Once the scan complete event is there, then we will trigger the service that's running on ECS. Now we have a container service that is running on ECS. Lucas, that could be running in EKS. Yes, it's a container after all. You could be running that anywhere. In this case, we wanted to run on ECS with Fargate because we wanted that to be simple. The focus here is not Kubernetes. The focus here is the solution overall and what we're doing with GenAI. But yes, you definitely could use. So the idea of this application running in ECS is it's going to get the findings from DynamoDB table. It already has the in-context learning example. So with the findings, it's going to build a prompt and then send to Bedrock. Because we have the example, Bedrock knows what to do, and then the application will clone the repository and open the PR. Important piece here, we are cloning the repository even before talking to Bedrock, because in the example, I have the current requirements. So I need to have the current requirements in order to create the updated one. So for that reason, we are cloning the repository as well. And at the end of the day, what you're expecting to get, it's a PR open to the source code with the changes on the requirements.txt file. But again, we are acting on that changes. It's not the model who is acting on updating the requirements.txt. We could ask the model to give us suggestions to update anything, and it could be up to us to get at something and updating our code. So that automation could really like scale to anything that you want to validate. If you have like patterns and blueprints and pipelines and all that stuff, I think that would apply. But this is the use case. And one thing this is important is once we merge everything in our repository, then the pipeline will trigger again because it's a cycle, right? CI/CD is a cycle. It will trigger again. And then this time, if we don't have anything critical or high, then inspector will not generate the event and the flow will not happen. But if the developers for some reason added a new library and they are using a deprecated library, the flux will happen again.
Got it. Lucas, I got to say, if I just looked at this slide to start, I wouldn't know where to start. But I think we just got a master class from you in how SAs, solutions architects at AWS, present an architecture diagram. That was awesome, man. It makes sense. All right, let's see how it works.
Now let's see if it works or not. So I have the image here already, latest. Let's open to see if inspector already has the scan. It's loading the image scan findings. Okay, this one has much more findings. And as you can see, there's like description, severity, and all the good stuff here that you can get from inspector. And then what is the next step of the architecture diagram after we have that inspector? Save the findings on DynamoDB. If we go to DynamoDB, before I didn't refresh the page because I want to show that we have actually added a new line here. Before, we're just the application that we use to build a prompt engineering example. Now, hopefully, okay, we have both applications. So we have my awesome application that we use for the example and my amazing application. ECR repo name is the partition key, and all the vulnerabilities are saved here. You see that we have fixed inversion, and in this case, it's not available yet because this is a Linux library. So probably to overcome this challenge, we would need to change the container image. And if you think about the life cycle of container images, usually we have teams responsible to define blueprints of container images and everything. But for libraries that are basically in the let me see if I find something. For libraries that are basically in the code, we have those updated requested. I'm not going to be open each item here, but this is the idea. So we have aggregated all the vulnerabilities here on DynamoDB from inspector. We are filtering by high and critical. This is a event bridge rule. I can show that for you folks afterwards. And after that, what we're going to do is event bridge would emit an event cluster. There we go. So event bridge would create an event called scan complete event. Inspector will generate that. And then we have the service that opens the PRs and talks to Bedrock deployed in ECS. We can actually see the logs for that service to see the invocation being done from event bridge to that particular service. So if you see here, there is a new request, and you can see the logs. It's starting ML validation for CV on repo, my amazing application, based on the image that we just sent. again, we clone in the repository, as I said, because we need to get the current requirements.txt. And then after clone the repository, we send that to the prompt. And this is basically some of the stuff that we sent to the prompt that is being logged by the logging library in the application. You can see that it already has generated the prompt. So the next step, what we do is we create a branch for that repository called CV Finder, and then we open the PR on the repository. So now, hopefully, if we open the My Amazing Application repository here, we should see a new pull request coming over. There you go. So CV Finder, please take a look and update with the following recommendations. And this was open 4 minutes ago, so I'm not lying here for you. It was happening when I was doing the architecture demonstration.
We are actually doing it live, folks. Love to see it. Now, so most of what you just showed us, Lucas, when you were showing us the entries and the Dynamo, all of that was just pairing together services in the right way, API calls, requests, Event Bridge, Lambda. Where the Gen AI piece came in was you needed an LLM to first, read all the data in, but then also give it an example for how you want the output of that data to look. Make it human legible, readable. Because usually when something like this happens, 2 a.m., some poor security engineer is getting paged and they have to figure out the issue in Inspector, open a PR, merge it. But I feel like, as a security ops engineer, your life is a lot easier if you just have to check the PR, hit merge, go back to bed. You're good.
Yeah, and we could apply that to many other different use cases. But let's open a PR to see what it looks like. And then I can show that we are actually using different libraries here. So you can see here that this is the PR that it opened. And if we compare to the in-context learning example, different libraries. It's not even the same application, but it understood the example that I gave it, and then it was able to do exactly what I was expecting it to do. So it has the updated requirements.txt file. And of course, we have, please note that the above are just examples. You should always check the vulnerabilities and recommend versions for specific dependencies. And I need to do some better parsing here on the action steps. I would like to have them one below another. But the most important piece here is that we have some changes. So it actually bumped some versions of all the libraries that Inspector have identified that needs to be upgraded based on those findings. And since we're not relying on the model to generate the data for us of what needs to be updated, this is up to Inspector. Next time that we run the pipeline again and a new image will be in the repository, the flow will happen again. So this is pretty good. And you can see that we let the libraries that doesn't have any CVEs identified by Inspector, and we put in place those that we needed to update to newest versions.
Amazing. Okay, so we saw it live. This flow works. Now, I think it's worth talking about what's next. Now, you've proven that this works. What gets you excited about generative AI capabilities like this, and what's in the realm of possibility? Maybe for our users watching back home, I know we can share a blog with them where you outline this flow. What should they expect to do with this content?
So I think, and I will ask Anton's opinion as well, but I think this is to show people that it's not super hard to build a Gen AI environment or microservice or application or whatever you want to call that. It's basically to have the same mindset that we have to automate. So what is the DevOps mindset? If you do something more than once, you are doing it wrong. If you can automate that something, you need to automate that, because if you are doing the same thing multiple times again and again, you are probably not being effective. So it's probably most likely you can automate that task that you are doing. So I think a lot of the automations we could have done in the past because of the way that the type of data that we have. Before Gen AI, we really would rely only on structured data, and we would need to do a lot of parsing to understand, to influence. And now we have those models that we can expand the automation capabilities beyond simply doing parsing, but actually taking action and understanding the context. So this for automation, it's pretty important. Some of the folks might know of GPT script or those type of projects. I think this is where we are going from now. As you said, if we can reduce the amount of time that the guy who basically wakes up at 3 a.m. I've been that guy in the past, wakes up at 3 a.m. Even before we start to troubleshoot, if we could have some sort of ability to visualize what's happening or talk to something without needing to access like clusters and all that stuff, that would be amazing. So I think the idea here is to show that Gen AI could be applied to many use cases. I think it's a matter of finding the use case that really matters and that you really can use and take the benefit of Gen AI. And moving forward with that solution, what we would want to do is we're partnering up with NVIDIA to expand that solution to do much more validations other than just the requirements.txt. And Anton can add on top of that. But I think at least this is like what we're aiming to do, and this is why it's important for me.
Yeah.
And you're referring to Morpheus, right, Lucas?
Morpheus.
And
Right.
I'll share a link to that in the chat here. By the way, you have some fans in chat. They love your demo. I've got to agree. Love your demo. All right, Anton, I want to give you a chance to answer that question as well. We've got you on the couch right now. What are you excited about? What's next for folks that are following your blog?
So this is starting to go into the questions you've asked in the very beginning, right? The secret of success and solution, how to be a good solution architect, etc. Right? You're never done, right? Whatever solution you build, right? You're always thinking about what's next, right? Because there's always going to be new problems to solve, right? So here, I want to emphasize this again, right? So when we started building this, we wanted to create a framework, right? And this framework, it doesn't necessarily mean that every single organization needs to build their own solutions, right? Realistically, there are probably going to be a set of vendors that implement it for others to use, right? Implementing this end-to-end CI/CD security is not everyone's bread and butter, but the framework is pretty extensible. To give you a few examples, right? So we're doing, and again, full transparency, pretty blunt, right? We're using Inspector to get the report, and then we're acting on that report, right? We're not doing that scanning on our own, right? We're using a tool for that. Now, imagine, I've already mentioned SonarQube, right? Imagine you have a tool that does static code analysis and gives you recommendations, right? That, you know, here and here and here you have problems. I hope many here have seen the output from SonarQube and similar tools now, right? Now, imagine those recommendations are now automatically actionable, right? So instead of saying, hey, Mr. Developer, right, or Mrs. Developer, you need to fix your code, right? No, we've tried to fix it for you. It might not be 100% perfect, but hey, review this, right? We've given you a head start, right? This is one of the options. Now, the other option, and this goes into the our partnership with NVIDIA, this is the stuff that I'm super excited about, right? Now, there's a process that many organizations have, and it's called something like AppSec review, right? Before you ship something, you need to go through a security review. Now, there are different flavors to those security reviews, right? You know, it might be some security team experience with security, and they will send you a questionnaire, and you need to fill that questionnaire. Or maybe they ask for your infrastructure code template, and they use something like Chekhov or any other tools, CDK-NAG, to validate it. But the bottom line is there's this ping pong that can go for days or weeks, right? They need to validate that what you're shipping, right? You know, it's big enough, you know, to warrant a security review. Now, imagine that being automated. Imagine GenAI can take a look not just at your requirements.txt, but at your larger application and figure out what are the right security questions to ask. Moreover, what are the answers to those questions? Okay, so GenAI kind of arguing with GenAI, right? We're in a area right now, right? So the GenAI can figure out that, you know what, you're using you know, AWS services, they require IAM permissions. I've read the documentation for IAM. I know what the best practices for IAM permissions are. I can see that here and here and here, you're not using those best practices. Moreover, I guess that's the reason why you're not using those best practices. Can you confirm or deny? Something along these lines. So essentially, where we want to take it is from this very specific task of, you know, you need to update our dependency version from 2 to 7, right, to something that is not as easily definable, something that is much more vague, right? Something like, hey, you know, I have this lots of code and infrastructure as code. Can you help me to figure out the threat vectors for this, right? So something that manually the AppSec team would do, right? Can GenAI help us with figuring that out, and then also helping to figure out what the resolution for that is going to be, and ideally generate a PR.
Anton, I feel like I'm so drawn to some of the ideas you presented here. Our viewers are probably as well. I might just have to go create a security startup. At this point, I think you've given us all of the technical steps required to create my own security AI startup. I don't know. Yeah. That's how I feel anyway.
I would highly encourage everyone to take a look at the Morpheus, right? It's also open source on GitHub, right? And we're working together with the NVIDIA team to publish some material like enablement and blog explaining how this works together with AWS. We already have some early prototypes going on, right? So expect to see this soon, right? It's pretty awesome to use, right? When you see the logs, right, where the model is arguing, right, analyzing your sources, it's just amazing. Yeah, Lucas, you can show this stuff. So look at this, right? Can you go to the previous one? Right, this is literally a discussion going on inside of LLM, right, about what might be a problem and what might be a resolution, right? And this is
based on the source code repository. Yeah, right, based on the source code repository,
right? This is, you know, a robot arguing with a robot about how to make your stuff better. Okay.
And then you have at the end an output.json that we can act on top of that. And one thing that's good about Morpheus, and I will basically copy with Alan from NVIDIA that are helping us set, if Morpheus doesn't know, because security is a super sensitive topic, so if Morpheus is not sure, it prefers to say, I'm not sure, then reply something that it's wrong. So this is the idea on how we are expanding that moving forward.
Yeah. So note the reason here, right? So this is great. The CVE is not exploitable because of whatever the reason is. So there is a CVE, but we've analyzed your setup, your code, your infrastructure and code. And while that CVE is, you know, applicable to the version of framework you use or whatever, it's not exploitable because of your application configured in a particular way. So while you might want to fix that, it's not like burning red, right? It's not urgent. You don't need to wake up people middle of the night for doing that. Right. So this is the level that we're trying to get to.
Amazing. First, I want to thank both of you. Lucas, awesome demo. Anton, really just great high-level overviews of everything that we've discussed so far and diving deep as well. Folks, at the beginning, I told you I would ask Anton and Lucas as well for insights into how they've been so successful in their careers at AWS. Anton, what does it take to be successful? You're a principal solutions architect at AWS. Any insights that you can share with our viewers today?
So, wow, there are so many things I can talk about. Okay, so you've probably heard about leadership principles we have here at AWS, right? Everyone, like every single person here at AWS would have their favorite, right? There are 16 of them, right? You will obviously have your favorites. I'll probably talk about, you know, customer obsession kind of goes without saying, right? So this is like the cornerstone. But the two that I like in my job, and they help me a lot, are first, learn and be curious, right? And I cannot express how much of that we have available here at AWS, working with all the customers as a solution architect. You have so much potential for learning new stuff, like literally every single day, right? So you have to prioritize your learning, right? This is like a really good problem to have. Okay, so learn and be curious. I think this is one of the big parts of being successful. You have to understand what your customers are doing, right? You have to be excited about that. And you have to always be a little bit ahead, right, to make sure you're helpful, okay? And the second one is dive deep, okay? I cannot tell you how many times I had to, I'm a serverless guy, right? I had to go and look at some source code for Lambda, not a particular Lambda function, the Lambda service, right? So it's completely up to you how deep you want to dive, okay? Completely up to you, right? But this is something that personally for me is super helpful, right? I enjoy diving deep a lot, and I think it is part of my success.
I love it. Anton, for folks that want to get in touch, maybe reach out, is LinkedIn a good way to get connected with you?
Absolutely.
Awesome. And Lucas, I want to ask you the same thing. Honestly, your career is super. It's something that I think a lot of people look up to. You started your career at AWS, I think about 4 years ago in Brazil. Today, you're in Austin. You're a senior solutions architect, and in my opinion, absolutely killing it. What's your secret?
I just love IT. I just love DevOps. I just love that's true, man. So I think I would not do that for free. Of course not. I would not do nothing for free unless my wife asks me something. But I really love work with IT. So for me, it's a pleasure that I have for myself when I know that something is working. So for instance, me and Anto, we start to discuss about should we build something around CVEs and everything. I didn't rest until I had something ready to go that we could do a POC with, because that was in the back of my mind. So this is usually the way that I work and learn for myself. The way that it works for me is I need to get my hands dirty, and the blocks in my hand needs to make sense. It needs to connect to each other, because we know a lot. There's a lot of concepts that can help you out. So if I can give any piece of advice for anyone who wants to start with IT, would be don't focus on the tool so much, but focus on the problem and the challenge that you are trying to solve and why you are solving those challenges and problems. To understand Kubernetes, if you don't know networking and Linux well, it's going to be harder for you than it's for someone that has a sysadmin back experience. So I think for me, I agree with everything that Anton said, but for me is that ability in AWS to visualize many use cases, be able to get a real understanding of those use cases, be 1 year ahead of the customers and help them out with those use cases that you are able to see because you have a broader view of the market. But for me is I need to get my hands dirty in anything that I do, anything.
Love to hear it. And I think super inspiring story. Go on, Anton.
I think we can throw one more thing into the mix here, right? Lucas briefly mentioned that. Here at Amazon, we call it work backwards from customer requirements, right? There are books written about it, right? I think this is critical, right? You can always do it for fun, right? But when you're doing this as your job, as your business, make sure that you have a valid business case, valid requirements that you're addressing, and you're not just playing around, right?
Otherwise, you're not feeling that you are being a valuable resource or something like that.
Success is not how you judge yourself, right? Success is how others look at you.
That's right. And if there's one takeaway that I think both of you do really well, it's not just doing the work, but doing the right work and putting yourself out there and making sure that you externalize some of these things. Really inspiring stuff, guys. Honestly, I feel like we could do an entire episode for folks watching at home on maybe their journey into becoming an AWS solutions architect. It's a well-paved path. A lot of experts have done it. And I think it's a great career path for folks watching. Not to get too far off the topic here, folks, but again, thank you so much, Anton, Lucas, for joining us on Containers from the Couch, showing us an awesome live demo. Lucas, if folks want to get in touch with you, any socials you want to share, or is LinkedIn good?
LinkedIn is good. So if you search by Lucas Duarte, you're going to find me on LinkedIn. But I also have a YouTube channel site. So let me send you the YouTube link so you can share with those guys. It's all in Portuguese. We have some titles. We are trying to add all the subtitles as I can in all the videos, but I just don't have time. But in my channel, I talk a little bit about being an SA in AWS, a little bit of my journey I share with folks. So I think maybe it would be a good thing to share with that. Let me share the link with you.
Yeah, I'll share it in the chat here. I love to see it. That you're doing video content outside of just tech content. For folks that want to follow Lucas, this is a channel you run with your wife, right?
Yeah, it is. Actually, she is the owner. I'm just there to help her in recording stuff, but she is the awesome who is doing everything for the channel. We're pretty
love to see it. Love to see it. Again, thank you both. For folks watching at home, be sure to follow us at twitch.tv/AWS or subscribe to Containers from the Couch on YouTube to see more content like this in the future. Drop us a comment below. Let us know what you thought. Let us know if you have any feedback or content that you want us to feature in the future. We try to do this every Thursday at 2 p.m. Central, and we'll catch you next time. Thank you, folks.
Have a good one.